Hello students, welcome back to my channel once again. In this video, I am here with you all with my second part of the data structure presentation. In the last part, we discussed about stack and queue. Today, in this video, we'll discuss about variations in queue. So, the thing we'll discuss in this presentation is circular queue, the advantages of using circular queue, double-ended queue or DQ, the two special types of DQ, priority queue and applications of queue. Variations in queues. First one, circular queue. In a circular queue, all elements are arranged in a circle instead of a row or a line. In circular queue, a pointer may be used to ensure the maximum size is not exceeded. Pointer is reset to the initial value as and when the number of elements in the circular queue reach the optimum value. Now, what is the advantage of circular queue? Very often, in an array queue, the empty cells are generated at the front after deletion operation. Although there are many vacant cells, the queue overflow signal is given, preventing new entries. And this happens because as the rear reach the end, you cannot add any further element in the queue. Now, this deficiency is overcome in the circular queue. If both rear and front reaches max position, then the insertion cannot be possible until both are again reinitialized to 0 in case of a linear queue. Whereas this reinitialization is not required in case of a circular queue. Also, in the case of an array with a larger size, where insertion and deletion takes place with few entries, in a simple queue, most of the cell remains unused, resulting in a wastage of memory. But in the circular queue, what happens? As shifting of rear and front to 0 do not require, this never happens, as all the cells will be utilized at some point of time. Now let us view a pictorial representation of circular queue to understand how it works. So here you can see a circle, a queue is in circle with index position 0, 1, 2, 3, 4, 5, 6, and 7. That means we have total 8 cells in that. Now, though we can visualize it in circle, actually in the memory, it is a sequential simple queue. That means the queue is here with size 8, having index position 0, 1, 2, 3, 4, 5, 6, and 7. Initially, front and rear are at 0. Now, when we add elements, if you remember in the last video I told, in queue, one cell left empty, that is the rear position, the queue will become full if front is at the first and the rear reaches the last. So here you can see in this second part figure, the queue is already full. Now if we delete some elements, so 2 elements deleted, front shifted from 0 to 2. In normal queue, you cannot access these 2 elements because rear is already at the last, rear cannot move further, and you cannot insert at front. Now in circular queue, what happened? We can move the rear from this index still to the front again. Now see, after 2 elements deletion, there is a room for 2 more elements to be added. And see in the next figure here, the last one, 17 added, 18 added, rear reaches at index position 1. Now the queue is again full. So in this way, the queue moves in a circular fashion. So 0, 1, 2, 3, 4, 5, 6, 7. Again it moves to 0. Let us see another image to get a clear picture. See here, I've shown in this table how this increment takes place. So when rear or front both are at 0, if I add 1 and then modulus by the size, it comes 1. Then 1 plus 1 modulus size 2, 2 plus 1 modulus size 3, 3 plus 1 modulus size 4, and so on. If the size is 8, 7 plus 1 modulus 8 becomes 0. So we can see here in the figure, I'm adding few elements, rear get incremented. When the rear is full, the queue is full. Now if I delete the elements, front get incremented. As the front get incremented, there are rooms in the front. We can easily move the rear from the end to the front to add element. And further, we can add like this. So again, queue is full in the last. Let us explain this concept through a program. So I have here a circular queue with a data member CQ as an integer array, F and R representing the front and rear capacity to get the size. We have push at rear, remove at front, normal condition that is there in queue. If the queue empty, it returns minus 999. Let us see the code. Here in the parameterized constructor, taking the size to capacity, front and rear initialized to 0. Allocate the memory for the array CQ. Now in the push function, you can see one additional thing in compared to the previous queue operations. What I have done, if I have to increment the rear, we are doing R plus 1 modulus capacity. Now if R plus 1 modulus capacity reaches front, F, my queue is full. Otherwise, the element is added and then I'm incrementing R equals to R plus 1 modulus capacity. Right? This additional statement I have given to show the position of front and rear. It's not actually part of scheduled program. Let's move to the pop function, that is removing at front. When I'm removing at front, the basic condition remains same. That is front and rear both at same position, queue is empty. Now here you can see we are not reinitializing front and rear to 0, unlike the simple queue. Because where it is left, from there again we can start entering. Otherwise, element is stored in N. Front equals to front plus 1 modulus capacity. Here again I'm printing front and rear position and returning the value. Now in circular queue, we have to divide it in 2 lines or 3 lines rather. Now the display part. In display part, I always starts from front. Here I not equal to rear, will not give less than or greater than, because sometimes rear can be greater than front, sometimes rear can be smaller than front if it is appearing before front. So the actual condition will be I not equal to rear and increment will be I equal to I plus 1 modulus capacity. Let us see the output. If I run this program, see here, I have already pre-run the program with the output. So elements added. So 4 elements added, each time front at 0 and rear getting incremented. Finally, when the queue is full, I'm displaying the element 10, 11, 12, 13. Now when I'm deleting, front get incremented. When front and rear both at 4, again queue is empty. Now again I'm adding some data. See, front remain at 4, queue get incremented, rear get incremented 0, 1, 2, 3. Again queue is full. Now elements are 20, 21, 22, 23. So it goes on in that order. Now we'll move on to the Deque portion. Deque or double-ended queue is a special queue where we can add the elements in the rear as well as in the front. Similarly, we can delete elements from the rear as well as from the front. So it is a double-ended queue in which the data can be added or removed at either end. However, in a Deque, neither data can be inserted or removed at random position. The word Deque is pronounced as Deque or DQ. The DQ stands for double-ended queue. A DQ is an ordered collection of elements from which new elements can be added or deleted from either the first or the last position of the list, but not in middle position. Now there are two special type of DQs. One is input restricted DQ, another is output restricted DQ. Input restricted DQ, a DQ in which items can be deleted at either end, but insertion can only be done at one end, that is rare. Whereas output restricted DQ, that means insertion can be done at either end, but deletion can be done at only one end, that is front. Now see, this is the image of a DQ. Here from the rear we can insert as well as we can delete. Similarly, we can insert at front and as well as we can delete from the front. That means insertion at rear and deletion at front is a normal queue, whereas additional two functions I'm getting insertion at front and deletion at rear. Now there are some preconditions. Insertion at rear is normal, we all know, until it reaches the size we can insert. But in insertion at front, that will be only possible when there is room in the front. That means if you have deleted something from the front, then only you can insert at front. Similarly, if you delete something from rear, you can insert from rear. Input restricted DQ and output restricted DQ we have already discussed. Though it is not in your syllabus, you can practice it out. Now see how DQ operates. Here is an example of palindrome checker. You can see in a queue, I have added a string radar, R-A-D-A-R. Now, if I remove one element from the front as well as at the same time remove one element from the rear and both get compared, they are equal, I'll move on to next deletion. Again, next element from one element from front get removed, another element from rear get removed, both are same, again the repeated. If they are matched, the step is repeated, and if at any point they are not matched, we abort the step. And in this process, if queue becomes empty, the string can be said as palindrome. Now DQ, we can use DQ as a stack and queue as well. How? See here, when the insertion and deletion move both made at the same end, then we can assume DQ operates like a stack. At the same time, if the DQ, they are at one end I'm inserting element and only at another end we are removing, it is acting as a queue. Now application of DQ, where is an application comes? First is steal job scheduling algorithm. What is steal job scheduling algorithm? A steal algorithm implements task scheduling for several processors. The processor gets first element from the DQ. When one of the processor completes its execution of its own thread, it can steal a thread from another processor. It gets the last element from the DQ of another processor and execute it. That means in a multiprocessor system, all the processors are working on a sequence of tasks. If first processor finished its work, it can get the task from the next processor at the back. And it goes on. Another one is undo redo operation of software. You can see when we do undo, how much you have undone, that much you can redo. If you have done redo something, that you can again do undo. So here DQ operations works. Now what are the operations in DQ? Insertion at the back, that means at rear end. Insertion at front, that is the front end, removing element at front and removing element at back. Now let us go through the DQ through an illustration. See, I have given here. So initially front and rear at 0 and the queue is empty. Now adding 3 elements. What are the 3 elements added? 10, 12, 15. Rear comes to position 3. Front is at 0. Now if I further add, now here you can see insertion at front is not possible because front is already at 0. Now if I delete one element from the front, that means 10 gets removed, deleted. Front comes to 1. Then I can add at front. So adding one element at front, that is 16, front again goes to 0. Now, when we add elements at rear and rear reaches the last side, we cannot insert at rear again. But if we delete elements, we are deleting 2 elements front, we can insert at front and we can delete some elements from rear. So see here, in the last operation, after deleting 2 elements from front and 2 elements from rear, front and rear both sides at index position 2 and the queue is empty. Now here also, we don't need to reschedule front and rear again back to 0. Where it is ended, from there again we can add elements. Let us see an example of DQ. So DQ, we have 4 functions. 2 functions are from the simple queue, that is push at rear and pop at front. Those are the 2 basic operations of the queue, if you remember. But we add 2 more functions. One is push at front and pop at rear. So let us go through it. So this is my DQ array, front and rear at 0. Excuse me. Push at rear, we are not discussing in detail. It is, as we all know, in the simple form. If queue rear reaches the last index, insertion not possible. Otherwise, we store the element and increment the rear. Push at front. What I'm doing, if front is already at 0, you cannot insert at front. But if front has shifted from 0, that means you have deleted some element at front, I can make front again come back to one step previous to previous index and element can be added. So here I'm doing DQ minus minus front. So you can see here in push at rear, we are using post increment operation on the rear, whereas in push at front, I'm using pre-decrement operation on front. Next, pop at front is normal pop procedure of the simple queue. If both are at 0 or both are at, here both are at same position, front and rear at same position, queue is empty. Otherwise, it is returning DQ front plus plus. When it is pop at rear, the condition remains same. Front and rear both reside at same index, queue is empty. Otherwise, it is DQ minus minus rear. So you can notice here, pop at front is using post increment operation on front. Pop at rear is using pre-decrement operation at rear. And display is the same. From front to rear, you are displaying the elements. I hope you have understood. Now we'll move on to priority queue. Just a basic concept I'll give on priority queue. It's not there in ISC syllabus. Priority queue is a queue in which insertion and deletion is as normal as in simple queue, but sometimes it changes when the priority gets changes. So what is priority? Every element added to the queue is set with a particular priority. So if an element have equal priority, then the usual rule applies, that is first in, first out. Otherwise, according to the priority, the element will be worked out. Now, there are 2 types of priority, ascending priority queue and descending priority queue. In ascending priority queue, the elements are inserted arbitrarily but deletes the element with the smallest priority first. In descending priority, elements are inserted arbitrarily but deletes the element with the largest priority. So, A priority queue is used when objects are supposed to be processed based on priority. It is known that a queue follows first in, first out algorithm, but sometimes the elements of the queue need to be processed according to the priority. That is when the priority queue comes into play. Priority queue is based on priority heap. The elements of the priority queue are ordered according to the natural ordering. The priority queue is a data structure in which elements are ordered by priority, with the highest priority elements appear at the front of the queue. Let us see here an example. So you have a priority queue. A queue is there. Initially, it is empty. The operation I'm doing, it is a character array I'm taking, example. We are adding some elements, NQ, and we are setting a priority. So NQA, and I'm giving priority as P2. So in the queue A is being added. Then I'm doing NQB, priority set as 1. Now I'm doing NQC with priority P2. So when I'm del Q now, so priority P1 will be executed first. So element deleted B from the queue. I'm again adding NQD with priority 3. Then I'm doing NQE with priority 1. If I del Q now again, it will E be removed. Then again I'm doing priority with F and so on. So whatever elements I'm adding, I'm setting a priority to that, and accordingly it is working. Now let us see some application area of priority. First is task scheduling. In operating system, priority queues are used to schedule tasks based on their priority level. For example, a high priority task like a critical system update may be scheduled ahead of a lower priority task like a background backup process. So sometimes two simultaneous applications have been put on for execution. Whichever is the highest priority will override the lowest priority or suppress the lowest priority process. In real life example, let us take emergency room. In a hospital emergency room, patients are tried based on the severity of their condition, with those in critical condition being treated first. So priority queue can be used to manage the order in which the patients are seen by the doctors. Network routing. In computer network, priority queues are used to manage the flow of data packets. High priority packets like voice and video data may be given priority over the lower priority data like email and file transfer. Transportation. In traffic management system, priority queue can be used to manage traffic flow. For example, an emergency vehicle like ambulance may be given priority over other vehicles to ensure they can reach their destination quickly. And the last one, job scheduling. In job scheduling system, priority queue can be used to manage the order in which the jobs are executed. High priority jobs like critical system updates may be scheduled ahead of lower job priority like data backups. So that's all from my end. Thank you for watching. I hope you understand the entire concept of stack, queue, and variations in queue, that is circular queue, DQ, and priority. Good night.